Good evening, ma'am. Myself Parijatan. I am studying BTech second year in Srinivasa Ramanujan Institute of Technology in the branch of CSM. So my topic is about Euclidean distance, most common and best for continuous data. So, when it comes to introduction to Euclidean distance is the measure of the straight line distance between two points in Euclidean space. This Euclidean distance is one of the most common used distance metric. It is used to calculate the distance between the two data points in dimensional space. It is commonly used in various fields like machine learning, statistics, and geometry. So, this metric provides a clear geometric interpretation of the distance between points. So, when it comes to the next slide, mathematical definition of the Euclidean distance is the Euclidean distance between two points. Those are p of x1 comma y2 y1, and another point is q is x2 comma y2, is calculated as between the distance between these 2 points is square root d equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So, this formula can be generalized to higher dimensions for points in n-dimensional space. For if there are three-dimensional space, another coordinate is added. So, that is x2 minus root of x2 minus x1 whole square plus y2 minus y1 whole square plus x3 minus y3 whole square. So, the computational involves using the Pythagoras theorem reflecting its geometric origin. This Euclidean distance is calculated based on the Pythagoras theorem. Pythagoras theorem is used in trigonometric, that is hypotenuse square equal to side square plus side square. This formula is called as the Pythagoras theorem. So, the properties of Euclidean distance. When it comes to the another slide, the properties of Euclidean distance. What are the properties of Euclidean distance, please? Euclidean distance is non-negative. It means it doesn't take any negative values. So, the meaning is it is always 0 or positive value. It takes only Euclidean distance. So, it satisfies the triangle inequality, indicating that the direct distance is always less than or equal to the sum of the other distances. So it is symmetric, means it's same, looking like same. The distance from point A to B is the same as from B to A. When it calculated from A to B or B to A, the distance is same. It is called as symmetric. So, use cases in data science. These Euclidean distance where we use in data science means so Euclidean distance is widely employed in clustering algorithms. This clustering algorithm is one of the best and algorithm in machine learning, such as k-means, and it also plays a crucial role in classification methods. K nearest neighbors, this classification is used. This k nearest neighbor is one of the algorithm in machine learning. It is used to calculate the similarity between the two data points. There are one point is given, based on that point the every point is compared to identify or clarify the nearest between the data points. So, in regression analysis, it helps evaluate the fit of models by measuring error distance between predicted and actual values. Between these values, that predicted and actual values, in measuring the error distances in regression analysis. So, the when it comes to the another slide, so the advantages for continuous data. What are the advantages for continuous data? Means Euclidean distance is particularly effective for continuous and numerical data due to its straight line forward interpretation. So the second one is it captures the actual spatial separation between data points, making it suitable for geometric analysis. So it is one of the another advantages of continuous data. So the third one is continuous data often follows a normal distribution, aligning well with the assumption of the Euclidean distance. Based on the Euclidean distance, it can be calculated for normal distribution. So when it comes to another slide, limitations of Euclidean distance. So what are the limitations of Euclidean distance? Means Euclidean distance can be sensitive to outliers. Outliers means which are not relevant to our data, called outliers, which may disproportionately affect the distance calculation. So it assumes that all features contribute equally to the distance, which may not hold true in all data sets. So the third one is in high dimensional space, it may lead to the curse of the dimensionality where distances become less meaningful. So comparison with other distance metric, how this Euclidean distance is very special when it compared to other distance metric. So unlike Manhattan distance, which measures absolute difference, Euclidean distance considers the geometric layout of the points. And the second one is cosine similarity, focus on the angle between vectors, while Euclidean distance measures actual distance between the data points. So each distance metric has its own strength and weakness depending on the data set and the analysis objectives in their perspective. So the visualization of Euclidean distance. How Euclidean distance looks like means visual representation can enhance understanding of Euclidean distance between points in 2D and 3 dimensional spaces. So graphs depicting data point and their distances can illustrate clustering and separation. So, visualizing the distance can help identifying outliers and correlation with the data point. This visual representation of the Euclidean distance can help identifying the outliers in data and correlation and relation between the data points in between two or more other points in dimensional within the data only. So the applications is machine learning. What are the applications employed with Euclidean distance in machine learning means many machine learning algorithms employ Euclidean distance for clustering and classification tasks. So it is integral to unsupervised learning methods. In unsupervised learning, there is no label data present in the unsupervised learning. So helping to group similar data points. In this supervised unsupervised learning, this Euclidean distance is used to group the similar data points in the dimensional space. So the second one is in supervised learning. Supervised learning use the label data. It means the predefined data is present in this. So in supervised learning, it assesses it finding the nearest neighbor for classification purpose. So calculating Euclidean distance in Python. How we calculate the Euclidean distance in Python means Python libraries like NumPy and SciPy provide built-in functions for calculating Euclidean distance effectively. So sample code demonstrates how to compute distance between array representing data points. The arrays are used to store data points in Python in any programming languages. In utilizing vectorized operations can significantly improve performance when handling large data sets. So when it comes to conclusion part, Euclidean distance is a fundamental concept in data analysis that measures special relationships between points. So its simplicity and effective make it a go-to for continuous data applications. So, in data analysis, understanding its properties and limitations is crucial for proper application and interpretation in analytical tasks. This is about Euclidean distance. So, thank you so much for giving this opportunity, and thank you, ma'am.